Hello everyone, I'm Brian Macon. Welcome back to the Math Fun Room. In this video we're going to begin learning about the hyperbolas. Hyperbolas are really interesting. They have some properties that lend themselves to some very exciting applications. But before we get to those applications, we need to first begin by defining the hyperbola and looking at some of their properties graphically. So let's get started. A hyperbola is the collection of all points in a plane, the difference of whose distances from two fixed points, called the foci, is a constant. This figure illustrates a hyperbola with foci f sub 1 and f sub 2. The line containing the foci is called the transverse axis. The midpoint of the line segment joining the foci is the center. The line through the center and perpendicular to the transverse axis is called the conjugate axis. The hyperbola consists of two separate curves called branches that are symmetric with respect to the transverse axis, the conjugate axis, and the center. And the points of intersection of the hyperbola and the transverse axis are the vertices v sub 1 and v sub 2. On this figure, we also have two line segments in the color red. These line segments are not on the graph of the hyperbola. They're being used to illustrate the definition of the hyperbola. One line segment connects the focus f sub 1 and an arbitrary point P on the hyperbola. The second line segment connects the point P to the focus f sub 2. The distance from f sub 1 to P and the distance from f sub 2 to P have a difference that is constant. And the constant is equivalent to the distance between the two vertices along the transverse axis. Now, with these ideas in mind, we're able to find the equation of a hyperbola in the rectangular coordinate system. In order to do this, we first place the center at the origin. Next, position the hyperbola so that its transverse axis coincides with a coordinate axis. For now, let's suppose the transverse axis coincides with the x-axis as shown in the given figure. If c is the distance from the center to a focus, one focus will be at the point negative c, 0, which we label as f sub 1. The other focus will be at the point c, 0 that we label as f sub 2. Therefore, the distance from f sub 1 to p minus the distance from f sub 2 to p is a constant value. We denote this constant as plus or minus 2a, where a is positive. If p is on the right branch of the hyperbola, then the distance from f sub 1 to p is larger than the distance from f sub 2 to p, therefore the difference is positive. If p is on the left branch, then the distance from f sub 1 to p is smaller, and thus we use the negative 2a as the constant difference. Now the coordinates of p must satisfy the equation that we just wrote. Now, using the distance formula from the point P to each foci, we can write this equation as square root of the quantity, the square of the binomial x plus c, plus y squared. Now we subtract from this the distance from f sub 2 to p, which we write as square root of the quantity, the square of the binomial x minus c, plus y squared. And again, this is all equal to plus or minus 2a. Now, to manipulate this equation into a useful form that will represent the equation of a hyperbola, we would need to do about 10 lines of algebra cleanup. For the sake of brevity, I'm going to skip that work here in this video. However, you should refer to the textbook to see the work completed for you. It's actually a fun derivation. We just don't have the time to complete it here. So anyway, after some simplification, we can write the equation in the form x squared divided by a squared minus y squared divided by the quantity c squared minus a squared equal to 1. For simplicity, we write this equation as x squared divided by a squared minus y squared divided by b squared equals 1, where b squared is equal to c squared minus a squared. Now on this slide, we present the equation of a hyperbola with center at the origin and transverse axis along the x-axis. The theorem states an equation of the hyperbola with center at 0, 0, foci at negative c, 0 and c, 0, and vertices at negative a, 0 and a, 0 is x squared divided by a squared minus y squared divided by b squared equals 1, where b squared is equal to c squared minus a squared. Now let's go on to a new slide and make a few notes about the points of interest on this graph. Now to find the vertices of the hyperbola, we can substitute y equals 0 into the equation. So the vertices would satisfy the equation x squared divided by a squared equals 1, or thus x is equal to plus or minus a. Therefore, the vertices of the hyperbola are at the points negative a comma 0, which we denote as v sub 1, and the other vertex is at the point a comma 0, which we denote as v sub 2. And notice that the distance from the center to either vertex is a, and thus the distance between the vertices is 2a, which is the constant referred to in the definition. Furthermore, to find the y-intercepts, if there are any, we would let x equal 0 in the equation of the hyperbola. This results in the equation y squared divided by b squared equals negative 1, or y squared equals the negative of b squared. Now this equation has no real solutions, so the hyperbola defined by the given equation in the theorem has no y-intercepts. In fact, let's also note we can take the original equation of the hyperbola and write it as x squared divided by a squared minus 1 equals y squared divided by b squared. Now if we think about solving for y, we would multiply both sides by b squared and then take the square root of both sides. So in order for y to be a real valued number, it must be true that x squared divided by a squared is greater than or equal to 1, or that x squared must be greater than or equal to a squared. So in other words, x cannot be between negative a and a if we want the y values to be real valued. So there are no points on the graph for x between negative a and a. Well, let's consider an example of finding and graphing an equation of a hyperbola. This problem says to find an equation of the hyperbola with center at the origin, one focus at the point negative 3 comma 0, and one vertex at 2 comma 0, then graph the equation. So let's begin by plotting the given information. Now, using an xy grid from negative 6 to 6 on both the x and y axes. And we're told the center is the origin, so let's plot a point at the origin. One focus is at the point negative 3 comma 0. We're going to label this as f sub 1 since it's to the left of the center. We typically label the points chronologically. Next, we will plot the given vertex, which is at the point 2 comma 0. And since this is to the right of the center, we're going to label that as v sub 2. Now, since the vertices are a distance of a from the center, then we know that a is equal to 2. Therefore, we could plot the second vertex at the point negative 2 comma 0 and label this as v sub 1. So in summary, we know that the vertices lie at the points plus or minus 2 comma 0. Now the foci we know are a distance of c from the center. Therefore, the given focus is at negative 3 comma 0, so c must equal 3. And we could plot the second focus then at the point 3 comma 0, and let's label this f sub 2 since it's to the right of the center. So in summary, we know that the foci lie at the points plus or minus 3 comma 0. Now, since all of these points lie on the x-axis, then it must be true that the transverse axis is the x-axis. And therefore, we know the general equation of the hyperbola has the form x squared divided by a squared minus y squared divided by b squared equals 1, where b squared is equal to c squared minus a squared. Now, to find the equation of the hyperbola, we already know a squared, so we need to find the value of b squared. And we know that a equals 2 and c equals 3. Therefore, we would have b squared equal to 9 minus 4, which equals 5. Well, this allows us to write the equation of the parabola as x squared divided by 4 minus y squared divided by 5 equals 1. And this is the equation as requested in the problem statement. So to finish the problem, we want to graph the equation. So to help us graph the parabola, it's helpful to locate and plot a few other points on the graph. Now it's common to plot 2 points on either side of the foci. So for example, in this problem, we can plot points above and below the foci that are located at x equals plus or minus 3. So let's substitute x equals positive 3 or negative 3 into the equation. And we write the square of plus or minus 3 divided by 4 minus y squared divided by 5 equals 1. A squaring positive 3 or negative 3 gives us 9, so the equation simplifies to be 9/4 minus y squared divided by 5 equals 1. We can isolate the y squared over 5 term in the equation by adding y squared over 5 to both sides of the equation and subtracting 1 from both sides of the equation. And after doing that and simplifying, we would have y squared divided by 5 is equal to 5 divided by 4. Multiplying both sides by 5, we would get y squared equals 25 divided by 4, and therefore y would equal plus or minus 5 halves. So now we have 4 points that we can plot. Those points would be where x is negative 3 and y is negative 5 halves, and then x is negative 3 and y is positive 5 halves. Positive 3 comma negative 5 halves, and positive 3 comma 5 halves. So finally, let's connect v sub 1 to the points at negative 3 plus or minus 5 halves with a smooth curve. This is the left branch of the hyperbola. Then let's connect v sub 2 to the points at 3 comma plus or minus 5 halves to sketch the right branch of the hyperbola. So a quick note about using a graphing calculator. In order to graph the equation x squared divided by 4 minus y squared divided by 5 equals 1, we would need to solve for the y variable to graph in function mode. So to do this, we would first begin by adding the y squared over 5 to both sides of the equation and subtracting 1 from both sides of the equation, and we could write x squared divided by 4 minus 1 equals y squared divided by 5. Now if we multiply both sides of the equation by 5, we have 5 times the quantity x squared divided by 4 minus 1 equals y squared. So using the square root principle, we would take the square root of both sides and end up with a plus or minus square root. Well, in other words, we would graph the two functions y1 equals square root of the quantity 5 times the quantity x squared over 4 minus 1. Now keep in mind this equation represents a function, so the positive square root actually will represent the upper half of each branch. Then we would have the equation y2 equals the negative of the square root of the quantity 5 times the quantity x squared divided by 4 minus 1. And this negative square root would represent the lower half of each branch of the hyperbola. In this example, we're told to analyze the equation of the hyperbola x squared divided by 9 minus y squared divided by 7 equals 1. And for the remainder of our conversation, the direction to, quote, analyze the equation, unquote, means to find the center, transverse axis, vertices, and foci of the hyperbola, and then graph it. Now this equation matches the form x squared divided by a squared minus y squared divided by b squared equals 1, with a squared equals 9 and b squared equals to 7. So we know that the transverse axis is equal to the x-axis, and the center is at the origin. Now let's find the vertices. And we know that the vertices are a distance of a from the center along the transverse axis. So they lie at the points plus or minus a comma 0. And since a squared is equal to 9, then the vertices will be at the points plus or minus 3 comma 0. Now let's plot these 2 points using a coordinate grid that goes from negative 6 to 6 on both the x and y axes. So we're going to plot v sub 1 at the point negative 3 comma 0, and then v sub 2 at the point 3 comma 0. All right, now let's find the foci. So we know that b squared is equal to c squared minus a squared, or c squared equals a squared plus b squared. And since a squared equals 9 and b squared equals 7, then we have c squared is equal to 9 plus 7, which is 16. So the foci are a distance of c from the center, lying on the transverse axis. So these will be located at the points plus or minus c comma 0, which will equal plus or minus 4 comma 0. So on our coordinate grid, let's plot f sub 1 at negative 4 comma 0 and f sub 2 at 4 comma 0. All right, in order to plot the two branches of the hyperbola, we want to plot a few more points. So let's move to a new page with some blank space. Now on this page, we still have our coordinate grid with the points we plotted. It's typical to plot points with the same x-coordinate as the foci. So let's plug x equals plus or minus 4 into the equation of the hyperbola. So our equation becomes the square of positive or negative 4 divided by 9 minus y squared divided by 7 equals 1. And this simplifies to be 16 divided by 9 minus y squared divided by 7 equals 1. So let's isolate the y squared divided by 7 term by adding it to both sides of the equation, as well as subtracting 1 from both sides. And we can write 16 divided by 9 minus 1 is equal to y squared divided by 7. Now multiplying both sides by 7 and getting a common denominator to subtract the 1, we have y squared equals 7 times the quantity, 16 ninths minus 9 ninths. Now this simplifies to y squared equals 49 divided by 9, and thus y is equal to plus or minus 7/3. So we want to plot the 4 points. To get an idea of where 7/3 lies on the y-axis, we can take out a calculator and note that it is approximately plus or minus 2.33. So let's plot all 4 points on our xy grid. We have a point at negative 4 comma negative 7/3 and negative 4 comma 7/3. The other 2 points will be located at 4 comma negative 7/3 and 4 comma 7/3. So let's connect v sub 1 at negative 3 comma 0 to the points at negative 4 plus or minus 7/3, giving us the left branch. And then we'll draw the right branch from v sub 2 to the points at 4 comma plus or minus 7/3.